Okay, so our next two examples will be taking a look at solving trigonometric equations. That means we're going to be solving for an unknown angle when we are given their sine, cosine, or tangent. So there's three steps that we want to take a look at. The first step is to determine which quadrants the solution or solutions will be in by looking at the sign positive or negative of the given ratio. That means that you will want to remember your CAST diagram, your CAST rule. Step 2 is to solve for the reference angle. Step 3 is to sketch the reference angle in the appropriate quadrant and then use the diagram to determine the measure of the related angle in standard position. Okay, so our first example, number 5, is to solve for an angle given its exact sine, cosine, or tangent value. So exact, meaning that you need to remember your special angles, right? 30 degrees, 45, and 60. So we're going to be asked to solve for theta. Our first one is sine theta equals 0.5, and we're looking for an angle which is between 0 and 360. So the first thing that you want to do is to determine which quadrant or quadrants your angle will be in. And because our sine of theta is 0.5 and the 0.5 is positive, that means that our sine ratio is positive. And if it's positive, we need to determine where between 0 and 360 sine can be positive, and that's where our CAST diagram comes in. Okay, so where is sine positive? Well, all trig ratios are positive in the first quadrant, so sine will, one of our angles will be in the first quadrant. And in the second quadrant, sine is positive. So that means we are going to have another angle, which is in the second quadrant. So we are going to have two solutions where sine of theta is equal to 0.5 degrees. All right, our second step is to solve for the reference angle. So sine of theta subscript r. Our reference angles are all going to have positive trig ratios, okay? So we can leave our 0.5 as 0.5. And the reason for that is your reference angles, if you recall, are between 0 and 90 degrees. And where sine is positive for sure, we know is in the first quadrant, okay? And so we can leave it at 0.5. Okay, now the other thing, because we're looking for exact values, sine of theta being 0.5 is also 1 over 2, and if you recall, you would need your 30, 60, 90 triangle to determine what the value of theta is when the sine ratio is 0.5. Alright, so here is your 60, 30, 90 triangle. Remember, opposite the 30 degrees, the side is 1. Opposite the 60 is root 3. And opposite the 90 degrees is 2. Now we know that sine of theta is opposite over hypotenuse, which means that our side 1 is going to be our opposite side. Okay, and then of course our hypotenuse is 2. But if 1 has to be the opposite side, what angle is it opposite to? And it's opposite the 30-degree angle. So that means that our reference angle, theta, is 30 degrees. Okay, so step 3 is to sketch the reference angle in the appropriate quadrant or quadrants. Well, quadrants in this case, right? Because we're going to have two answers. So let's draw that. Okay, so whatever our first angle is, it's in the first quadrant. And we also have a second angle which is in the second quadrant. So theta can either be here or here. All right, we do know that we have a reference angle of 30 degrees, so in the first quadrant it is here, and so theta subscript r equals 30. And in the second quadrant, it's right here, right, between the terminal arm and the x-axis. So we get our reference angle of 30 degrees in the second quadrant. Okay, well, as you can see from the diagram, our reference angle and our first angle in the first quadrant is the same. Okay, so our first quadrant angle is 30 degrees. Our second quadrant angle well, we would calculate it because we know that half a circle is 180 degrees. We know that up to our terminal arm is unknown, but between the terminal arm and our x-axis is 30 degrees. So I can find theta by minusing 30 from 180, and I find that my second quadrant angle then is 150 degrees. So the last thing that I want to do then is I want to state my solution. So the solution for sine of theta equals 0.5, where theta is between 0 and 360 degrees, is that theta could be 30 degrees or 150 degrees. Okay, so that one is now solved. So now let's take a look at our next example, B. We are asked to solve cos of theta equals negative root 3 over 2. And take a look at your restrictions now. Your angle theta can only be between 0 and 180 degrees, which means that there's only a possibility that it could either be in the first quadrant or the second quadrant. Okay, no other quadrants. So let's determine which of the two it is. We know that cos of theta is negative root 3 over 2, and because negative root 3 over 2 is negative, we know that our cosine ratio is negative. And so where are we going to find that cosine is negative? So we take out our cast diagram. And like I said, it can only be the first or the second quadrant. So we need to determine where our cosine is negative. Well, in the first quadrant, all our trig ratios are positive, so it can't be a first quadrant angle. But in the second quadrant, it's only sine that's positive. Cosine is negative here in the second quadrant. So therefore, theta is in the second quadrant. Okay, so now we want to determine our reference angle. In order to do that, I need to make my negative root 3 over 2 positive because my reference angle needs to be between 0 and 90 degrees. So I'm looking for something that could be a first quadrant angle, right? So I need to make that positive. Now, root 3 over 2 should suggest to you once again that this is a 30, 60, 90 triangle. So let's take a look. Here we have 60, 30, 90. Okay, so here's our 30, 60, 90 triangle. Side opposite the 30 is 1, side opposite the 60 is root 3, and side opposite the hypotenuse is 2. I know that cos of theta is adjacent over hypotenuse, and my root 3 needs to be the adjacent side. And so root 3 is adjacent to which angle? Well, root 3 is adjacent to the 30-degree angle. And And so I can see that my reference angle then, my reference angle is 30 degrees. Okay, so now I want to draw my angle in standard position and with a reference angle of 30 degrees. All right, so I know it's in the second quadrant. And I know that my reference angle is between the terminal arm and the x-axis. And so if I want to figure out what theta is in the second quadrant, I would go 180 minus 30 to get 150 degrees. Okay, and I know that I need to minus 30 from 180 because half a circle is 180. And when I subtract the 30 degrees, that will bring me up to this reference angle and tell me that the angle, which is indicated by the red arrow, is 150 degrees. And so then I state my solution. The solution to cos of theta equals negative root 3 over 2, where theta is between 0 and 180 degrees, is 150 degrees. Okay, so that ends this discussion for example number 5.